It's Saturday, June 21st, 2025, and we have a slight risk up here in the Great Lakes, extending all the way into the northeast, surrounded by a marginal risk of severe weather. Then we have another marginal risk back here in eastern Montana and western North Dakota, then one more marginal down here in Nebraska, extending up into eastern South Dakota. This is expected to be almost exclusively a wind and hail threat. We have a 15% slight risk of wind up here on our Great Lakes to northeast region, and this is going to be surrounded by 5% marginal risk of severe winds, as well as a 5% marginal risk of severe winds up here in our eastern Montana to western North Dakota risk area. And then hail is also going to be a possibility with these storms, but it's going to be mostly muted, with our greatest probability of seeing large hail out here in our Great Lakes region to northeast. And then we have a conditional tornado risk out here in the Great Lakes associated with the remnants of our derecho from yesterday. Then a 2% tornado risk up here in northeastern Montana and northwestern North Dakota. This is going to be pretty much already over as it happened early in the morning. Here's our simulated reflectivity from our northern plains risk area, and we can see remnants of our derecho out here over Minnesota pushing eastward, and that's going to continue to do it through the day, bringing mostly strong winds to the area and the risk of spin-up tornadoes and some hail. But what this storm has essentially done has stabilized the entirety of the environment back here. So what we'll notice as we go through the day, we're going to see pretty much no convection at all out here in this region, with the exception of some rain and wind possibly out here in eastern Montana near the evening to early night hours. And in our main risk area today, here's our remnant derecho moving across the very northern parts of the United States and the Great Lakes region. And we can see that it's expected to re-intensify a little at daybreak when the low-level jet increases for a short amount of time, possibly sprouting weaker storms that are expected to sputter in much of eastern Michigan, and then bringing that mostly wind threat to Canada with the threat of a couple of organized storms at the tail end on that outflow boundary of the remnants of our derecho, possibly affecting upper Michigan, and these could pose an all-hazards threat to this region. And lastly, our northeastern risk area is expected to see the remnants of our derecho pull through in the night hours, and this could possibly bring a spin-up tornado threat as well as mostly wind to this area. But what we see is that there's not a lot going on here at all because there's just so much capping and stability in the atmosphere. Here's our 500 millibar winds from the NAM, which is going to show us where that large scale forcing is coming from. And we can see right here, we have a short wave over the Dakotas, which is going to push eastward. And that's going to be one of the main factors behind sustaining that mesoscale convective system or remnants of that derecho. As we push through the day, we see pretty strong forcing associated with that, which is going to help to sustain that. And then we see a little tongue down here, which would be very important for storms out here in eastern Michigan to fire, although they're mostly expected to be weak because of the stable environment right there. And this flow is expected to persist all the way into our northeastern risk area. And what we'd expect to see normally with something like this is a line of storms along this, but because of this stable environment down here, we're really not expecting to see much storms at all. And our 700 millibar winds, which has been huge for sustaining that remnants or derecho or MCV, is going to be really strong right behind it. Just keep pumping inflow into that storm and sustaining it throughout the day as it pushes across the northern United States and southern Canada. I'm not going to spend too much time on all of our photographs. This is a photograph from our Montana risk area, and what we'll notice is a pattern as we go through these. So this looks like a pretty formidable wind profile, and it definitely is. We have insane SRH, we have insane low-level shear, and we have insane deep layer shear. And the deep layer shear is definitely going to be a big factor in sustaining those storms that we already have that are organized, including the variant in our winds. But as we can see, we have loads of capping out here in this region, and our air is going to be extremely stable. So that's why we're not really expecting storms today, except where there's already organized convection. This is a sounding from upper Michigan, and once again, we see a pretty good wind profile, but insane amounts of capping and a pretty stable environment. So despite this, storms definitely won't even really be there at all to take advantage of this, except where there's already organized convection, possibly along the outflow boundary closer to the low from the mesoscale convective system in upper Michigan. But those storms could still struggle to get organized because of the amount of stability in the atmosphere today. And then last but not least, probably the craziest wind profile of them all is actually going to be in our northeastern risk area. But once again, surprise, surprise, despite this, our capping is going to be insane along with a very stable air mass. So the main possibilities with the areas of our MCV pushing through are going to be strong winds, a couple of spin-up tornadoes, and hail. And here's the analysis of last night's crazy derecho and those couple of wedge tornadoes we got out in eastern North Dakota, which most likely possessed strong to violent intensity. So we can see here in eastern Montana, we get a cluster storm which starts to build. And this is about when the National Weather Service declares that a derecho has begun. And then we get what we feared most. We get a couple of discrete storms out here in a very potent tornado environment. And these would go on to produce very strong tornadoes all the way until our derecho back here crashed into these storms. And as these were producing strong to violent tornadoes back here we got a big area of up to 100-mile-an-hour wind gust. In fact, winds in this derecho were anywhere from 100 to 120 miles an hour. And it wasn't just one gust front. These were sustained winds all the way through our big line of storms here. And then something insane that occurred is that we actually got the formation of a wake low back here with our derecho, which basically just pushes air towards the ground. And in this sector right here, we saw areas of up to 120 miles an hour of wind. And this was basically a hurricane up here in North Dakota because we have a bunch of sinking air around a low up here, which was actually reported to be around 950 millibars of pressure. And then on top of that, when our derecho crashed into our couple of discrete storms out here, it actually temporarily enhanced vorticity in these storms, which actually created the strongest tornado of the night, which actually slabbed a couple of homes and unfortunately caused 2 fatalities out here in eastern North Dakota. So let's take a look at our 500 millibar winds to help decipher the ingredients behind the setup that we saw last night. So back here we have a strong low with a trough digging in across the northern United States and a prefrontal short wave, which is going to be very important for the initiation of those couple of discrete storms out here in eastern North Dakota. And that is pretty much exactly what we saw with the initiation of a couple of discrete storms out here. And then back here with our larger amount of upper level forcing, a cluster of storms that would eventually turn into that derecho. Then our 700 millibar winds, which is very important for tornado genesis and sustaining MCVs, were just pumping across this region with a lot of southeasterly flow, which undoubtedly helped increase the strength of the MCV, which would eventually become that derecho and help with that tornado genesis with these storms. Okay, this is a sounding from our northeastern South Dakota and southeastern North Dakota main risk area where our ingredients were most prevalent around 0Z, so 6 p.m. Central. And with it being 6 and sunset being closer to 9, it's important to note that these ingredients probably got way better as we got closer to this time, but we can see that our vertical wind profile was already very potent with a lot of curvature in our low levels, then elongating out. Our surface SRH was already very high along with our low level shear, and this was before the low level jet even kicked in. So it's important to note that these actually probably close to doubled. And then our bulk shear was already very high as well, which helped to undoubtedly sustain these storms. We had some veering in our winds with very strong winds in our mid-levels, pretty high low-level lapse rates with a little bit of a capping inversion, but as surface heating continued, this likely eroded entirely. And then our LCL was still a tad bit high, but it's important to note that a little bit more north where these storms actually fired, it was most likely closer to the ground, below that 1 kilometer threshold. There was some dry air loft, which appeared like it would inhibit convection, but it actually kind of helped with lift once we got those storms above our capping layer at around 2 kilometers, and actually also helped to accelerate those downdraft winds and help increase that wind threat. And then our environment out here was beyond unstable, reaching around 5,000 cape at all levels. And our downdraft cape was also super high at around 1,500. So that's one of the reasons why that wind threat really peaked.